This information is from the previous page. I'm just going to pull this down so we can look at this. So we want to start with the miles per year. Here's Tammy driving 5,000 miles per year. And then the other information was provided here. Tammy's car gets 30 miles per gallon. Miles goes on bottom so that it can cancel with this. So 30 miles and 1 gallon on the top. The next fact is that there are 8,700 grams per gallon. That's that fact about burning gas. And the final fact is 1 metric ton over 1,000,000 grams. This comes from the fact that a metric ton is 1,000 kilograms, and 1 kilogram is 1,000 grams. So 1,000 times 1,000 is 1,000,000, and to save time, we just remember that a metric ton is a megagram, or 1,000,000 grams. So that's the setup for Tammy. Then you can go ahead and cancel what cancels. Gallons, gallons, grams, grams. We end up with tons per year. 1.45 metric tons per year for Tammy. And again, keep in context that the recommended emissions for a person for a year is 2 metric tons. So that puts Tammy in below that threshold. But of course there's other things besides driving that have emissions. So Tammy is using up quite a bit of the recommended emissions with just the driving. So you can go ahead and try to set it up for Ben and for Nayla in the next 2 problems and see how you do. Before we jump ahead, I did want to show you that the shortcut method here is to take 5,000 divided by 30 times 8,700 divided by 1,000,000. So that saves us multiplying across, and then dividing, which will also work. So do whatever you like, but this is sort of the shortcut that I like to recommend. And that should still give you 1.45 metric tons per year. The process for Ben and for Nayla is very similar. We'll see that Ben's carbon footprint is higher than Tammy's because Ben drives almost as much and drives a very inefficient van. Nayla has a Prius, so her carbon footprint is going to be a lot lower. And everything's basically the same except the first fraction, which is the miles driven, and the second fraction is the fuel efficiency. So Nayla's carbon footprint works out to be 0.63 metric tons per year. These carbon footprints depend on 2 things, miles traveled and car's fuel efficiency. The last 2 facts are this universal fact about burning gas and the conversion between tons and grams. So to simplify what we just did, we always take miles traveled, we divide by fuel efficiency, multiply by 8,700, and then divide by 1,000,000. So that's a sort of a nice, easy summary of the process we've been doing. Two more questions on this page. Grams of CO2 per mile traveled. We worked out something similar to this in the previous lesson. If we don't include the miles driven per year, we can compare different vehicles and modes of transportation. Use the fact that burning 1 gallon of gas generates 8,700 grams of CO2. So we're going to use that as a starting point, and then let's multiply that by 30 miles per gallon, or by 15 miles per gallon, and see what is the grams per mile. So grams per mile is what we're trying to end up with. So I put grams per mile over here as my goal. And then 8,700 grams per gallon is what I'm starting with, times, I need another fraction. So my next fraction, if I put 30 miles per gallon, you see how that's not going to work because gallons are on bottom right here. So what I need to do is put gallon on top and 30 miles on bottom. And now gallons will cancel, and all I need to do is 8,700 divided by 30, and that will give me my grams per mile. So equals, and then I go over here and use the calculator, 8,700 divided by 30 gives me 290 grams per mile. So I was kind of showing you the process of writing this down first, putting grams per mile over here next, because that's what you're trying to get to, and then you're like, oh right, I need to put gallons on top for that to cancel. And that way I'll end up with grams per mile. So this means every mile you drive, this car would emit 290 grams of CO2. And then same process for this van, 580 grams per mile, which is exactly double the emissions of this car, and that's because the fuel efficiency is exactly half of that fuel efficiency.